Okay, next chapter is logistic regression. Okay, logistic regression, if you have factors, okay, unlike neural net, the GLM method that we use for logistic regression, it will automatically generate dummy variables for us, full rank dummy variables. So we don't have to create dummy variables ourselves. We just give the factors as predictors, GLM will take care of it. So that's what you see here. So we can use the decision tree partition. Okay, we didn't do anything in decision tree, right? We used the variables as is. We can do the same thing. But in logistic regression, sometimes we may want to normalize the numerical variables. Okay, numerical variables, if you want to normalize in some fashion or some kind of transformation, you can use preprocess. So preprocess is one of the caret functions. Okay. So instead of using preprocess outside, okay, you can incorporate preprocess in the train function itself. Okay. We didn't do a lot of that, so don't worry about it. But that's something that one might want to do in logistic regression. So here, if you run this, okay, GLM is the method, binomial family, because GLM has lots of different. GLM stands for general linear model. It has lots and lots of methods. So we want to use for logistic regression, we need to specify that the family that we need is binomial, and that's going to give you the model. So some of the probabilities that fit was 0 or 1, so it gives you a warning. Okay. Now, if you want to use some sampling technique, then you have to set it up in caret. Okay. So we have, so let's assume that we want repeated cross-validation. So you need, for repeated cross-validation, you have to specify number of folds and how many repeats you want. Okay. So here I have a method equal to repeated CV. Okay, number of folds is 10, repeats is 3. Then I train the model. Okay, so high margin as factor, and then data is the trained data, method is GLM, family is binomial, and then TR control is that. Okay. So now we have the trained model. Okay. Now suppose we want all of these, when you don't specify what metric to use for training the model, the default metric is what? Accuracy. Accuracy is the default metric. If you want some other metric, okay, for example, the area under the curve, then you have to specify a couple of things. One is you need to use, in train control, you need these two, in addition to what you had before. Okay. You need these two things in the control. And then the target should be, you need to make the target a factor with the labels associated with the different levels. So here we have two levels, and the labels we are associating are no and s. So then we can use y equal to that y and x equal to here. Okay, since y is outside, this is wrong. X should not include high margin. So dt dot train okay. So high margin is the last one. Okay, so there are 9 variables, so I need to here say -9. Okay. Because we have coded high margin as Y, so high margin should not be used again. Oh, I haven't run this one. Okay. So now reg dot AUC, okay, so metric is ROC, okay, and now we can run that regression object, okay, model object, and do a prediction for the valid data set. You can do probability for valid data set, and then construct your confusion matrix or generate your ROC chart.